Now we're getting into the unit circle, and we're going to see what the usefulness of the unit circle is. So as mentioned, a unit circle is a circle with a radius of 1. So we're going to take a look at a couple of points that are formed by the unit circle. So if you think about dropping a right triangle, dropping a line straight down to create a right triangle, you can see that the horizontal side of the triangle is the x-coordinate of the point on the unit circle. The vertical side of the triangle is the y-coordinate of the unit circle. And because it's a unit circle, it has a radius of 1. So we can use this right triangle to set up our 6 trig ratios. Sine is opposite over hypotenuse. Remember this angle right here, I don't really have room to write theta in there, but this angle at the origin is theta. So from theta, opposite is y, and hypotenuse is 1. So the sine value is the y-coordinate of any point on the unit circle. Cosine is adjacent over hypotenuse. The side adjacent is x. Again, the hypotenuse is 1, so our cosine is x. So again, any point on the unit circle, the cosine is the x value. And tangent is sine over cosine, or y over x. And of course, our 3 new functions are the reciprocals, so cosecant is 1 over y, secant is 1 over x, and cotangent is x over y. So any point on the unit circle, we can generate all 6 trig functions. So let's see how that works. We're going to start with an example. We've got a point on the unit circle. Obviously, theta is a negative angle because of the rotation. And the point is the x-coordinate of the point. Of course, you guys know x comes first, is 12/13. And the y-coordinate is -5/13. Sine is the y-coordinate. It's kind of backwards. We're used to doing sine and then cosine, but sine is the y-coordinate. So there's lots of things about trig that are backwards, like you would expect sine and secant to be reciprocals, but they are not. You would expect sine to be the x-coordinate, but it is not. So just go against your gut with trig and you'll probably get it right. Cosine is the x-coordinate, so that's the 12/13. And then tangent is sine over cosine, so we can multiply by the reciprocal when we've got our fractions. The 13s cancel, and our tangent is -5/12. Once we have the first 3, we do the reciprocal to get the next 3. So cosecant is -13/5, secant is 13/12, and cotangent is -12/5. Now that we've seen an example, I'm actually going to jump back to the unit circle, and we're going to go over the signs, positive or negative, of the trig functions in each quadrant. So if you want to write these down as references, in the first quadrant, and I'm just going to do sine, cosine, and tangent because the reciprocals will have the same sign, S-I-G-N, as the original 3 that they're reciprocals of. So of course the x, y coordinate in the first quadrant are both positive, so sine, cosine, and tangent will all be positive. And I'm doing actually cosine, sine, tangent, like those are in the ordered pair, so cosine comes first. In the second quadrant, the x-coordinate is negative, so cosine would be negative, sine is positive, and the ratio would be negative. In the third quadrant, both coordinates are negative, the ratio would be positive, so cosine and sine are both negative, and tangent is positive. And finally, in the fourth quadrant, our x-coordinate is positive, so cosine is positive, sine is negative, and the ratio is negative, so tangent will be negative in the fourth quadrant.